All right, so AP Calculus Lesson 1-7, Instantaneous Rates of Change. Yesterday was Average Rates of Change, and this is the calculus version of that lesson, Instantaneous Rates of Change. If we put yesterday's Lesson 1-6 with today's Lesson 1-7, and you set them equal to each other, you get Lesson 1-8, which is the mean value theorem. So in order to properly understand the mean value theorem, you definitely need to understand what's going on today. By the way, I should say that today's date is Wednesday, September 2nd, 2020. Our objective for the day, go ahead and read it, Fiona.
Draw tangent lines to graphs and recognize where a graph is not differentiable.
There it is, okay. So a bit of things to go in there. Tangent lines to graphs. So let's do that right now. Actually, let's do a bit of review. 1-6 was average rate of change. So what would be the average rate of change? How would I represent that graphically over the interval from A to D? What would you do? Graphically, what does it mean for an average rate of change? Yeah, Teflon?
Is it a line through A and D?
Exactly, yeah, boom, there it is. There is the line that goes through A and D, and then if I look at the slope of that slope of the line is the average rate of change, but first you have to draw that line. So what I'm gonna do now is I'm gonna play with that line, and I'm gonna go ahead and make it an instantaneous rate of change instead of an average rate of change. So to do that, I'm gonna use another color here. So let me come over here and say, I'm gonna do a red line. If I were to do an instantaneous rate of change, maybe I should have written up here, hold on. Let me label this so we don't get confused. This was the average rate of change, and that's over A to D. An instantaneous rate of change is just 1 point, not 2 points, which is, it seems like it's okay, but once you get to the definition of it, you'll be like, wait a sec, you're dividing by 0. So an instantaneous rate of change looks like this. For A, it touches A without ever going through the line. So if I were to drag this line, it barely touches A, and it's technically tangent to the curve. Again, we all remember from geometry, whenever we had a circle, we said, oh, you can have a line tangent to the circle. That's not a very good tangent line. Tangent to the circle, which means it touches once, and it also makes this 90-degree angle right here with the tangent line from the radius. This is what it means to be tangent also in calculus, but now it's not a circle, it's just a general curve. We can now apply that definition of a tangent line a little bit more generously. It touches just once, and it's the slope of that line is the instantaneous rate of change, just like the slope of this line is the average rate of change. So what I want to do now is just practice drawing a bunch of instantaneous rates of change. So try drawing it for B, and hopefully you should get a negative slope, like A was a positive slope. And actually, I can label this too. This red line is the instantaneous rate of change. Try drawing your instantaneous rate of change, at least the line that represents that, for each of these other points. So I'm gonna have a point that goes like this, shunk. It has to match that slope, oh gosh. Right about there. And then I have one that's right about there, and one that looks like that. It's kind of hard to see that one, especially for me. There's these tiny little lines. And of course, if I extended that line out, maybe it would intersect the function, but locally at that point, it does not go through the curve, it just touches it at 1 point. And I'll put down here that these lines that I'm drawing are tangent. Put that in parentheses. These should all be tangent to the curve. Okay, so in AP Calculus, there's all these synonyms that you need to know. Like if they say, what is your average rate of change? They're really asking for what is the slope, right? So if I'm looking for an instantaneous rate of change, there's a bunch of different names that you need to associate that with. How do I zoom? Be smart. Zoom is not being my friend right now. There it goes, okay. Instantaneous rate of change. Another name for instantaneous rate of change is a tangent line. tangent line. So if you ever see either one of these, that's the same exact thing that it's talking about. Another synonym for tangent line and instantaneous rate of change would be the derivative. And you guys, because you were in pre-calculus last year, you've seen how to take the derivative. Whenever you're taking the derivative, you're really finding the slope of the tangent line. And then another thing, you've seen derivative before, it's kind of like f prime. That means I'm taking the derivative. All of these things are talking about the exact same thing. Relate these to one another in your head. Okay, so lots and lots of sketching today. Let's go down to example 1. You don't need to write down all of these instructions. You just need to say, like the main thing is that you draw this function and then have these points roughly at the right spots. All we care about is the slope 0, is the slope positive, or is the slope negative? That's all I care about. And then the notation here is kind of important too. This is saying the slope of the instantaneous rate of change. Is the slope of the instantaneous rate of change positive? Is the slope negative? Is the slope 0? So I'll give you a sec to copy that down. All right, so again, we know what that notation means. So the first thing that I want you to do is to draw a line. So you're gonna come up here, I'm gonna grab a line tool. Draw your instantaneous rate of change for each of these points. Just need more practice at them. Again, it should touch at just one spot. I'll do one of them, and then I'll let you guys get started. That one. You do the next ones. Instantaneous rate of change. And it looks like you guys are all working really hard, so I'm gonna go ahead and draw them, and you can check up here to see if you have the right answers. Okay, so give me a thumbs up, thumbs down. Is that approximately what you guys got? Thumbs up from Chris, Fiona, Andrea, and Teflon. Yeah, nice, okay. So now for each of these, are these slopes positive, negative, or are they 0? And this is the notation on what you have to say. So this is saying the slope of the tangent at x is equal to a. So x is equal to a, it's talking about this point right here, saying the slope of this red tangent line, is that positive, negative, or 0? So let's do positive, thumbs up, negative, thumbs down, and then we'll do like a, I don't know, you can do a thumbs in the middle, I guess, for 0. So where's your thumb? Is it a positive slope, 0 slope, negative slope? See, 1 thumbs up, 2 thumbs up, 3 thumbs up, 4 thumbs up. Okay, yeah, so it is indeed, I'll come down here and say it's greater than 0. That means it's positive, right? Or notation. Okay, do them for B, C, and D as well. What is the slope? So you're gonna do all 3 of them on your own. Oh, you guys are all doing thumbs also, so everyone agrees that that one is negative. I guess we can keep doing thumbs. What about C? What is the slope at C? Positive, 0, negative? Everyone's saying 0. You're correct, so I say equal to 0. And what about D? The slope of the tangent line is negative. Yes, good. Very nice. Okay, so that's the drawing tangent line part of our objective today. Now we have to recognize where a graph is not differentiable. So differentiability, I should define it. And this is another one of those things that I'm gonna start making you guys just start calling out. So tomorrow I'm gonna ask you, what does it mean to be differentiable? And you say, it doesn't have these 3 things. So it's not differentiable if it has these things. These are the bad things. So if any of these are met, then you're not differentiable. So you're not differentiable if you are discontinuous. Okay, and because we've already gone over continuity, what are the 4 things that will cause you to not be continuous? You can use the Khan Academy term, or you can use my class term, whatever you want. Go back to your notes for, where do we do these? 1-4. Everyone look at your notes, 1-4. What are your 4 things that will make you not continuous in 1-4? Who's got the first one? Each one of you is going to do your own discontinuity. What's one of the discontinuities? 1-4. There's the category there with graphs. There's 4 graphs, and they say types of discontinuities. Chris, yeah, go for it.
Wait, I don't know if it's right, but the whole slash the removable thing.
Yeah, hole.
There's a gap or a jump.
Removable, exactly. So I'm just going to call it a hole because it's a little bit easier than writing removable. A hole. What's another one? Chris has one of them. Someone other than Chris.
It ends.
Ends, yeah. Holes, ends. What else? Teflon?
Is it the gap?
Gap, good. Ooh, I can't spell. Gaps. And Andrea?
Is it vertical asymptote?
Vertical asymptotes, there they are. Holes, ends, gaps, vertical asymptotes, those are the things that will make you discontinuous. And if you're discontinuous, I can't say that word. If you're discontinuous, then you're also not differentiable, which makes more sense once you see a picture of what it means to be not differentiable. But the first thing is you have to be continuous if you want to be differentiable. If you all of a sudden pick up your pencil, then it's impossible for you to be differentiable. All right, the second thing is, these are the 2 new things that you need to remember. Sharp corners. Sharp corners. And we can do a picture here. Chunk, like that, or chunk, like that. Those are sharp corners. Because they change their slope abruptly. The slope was 1, 1, 1, negative 1, negative 1. It wasn't a nice smooth change in the slope. And then vertical tangents. So vertical tangents mean that if I drew my tangent line, my instantaneous rate of change, just like I did up above, I drew my line where I have a slope that is vertical. Again, that means that you're not passing the, you kind of are passing the vertical line test. Because it's only at that one instantaneous point, but it looks like this. At this one point right here, you have a vertical tangent, because if I drew that tangent line, the tangent line would be going vertical, straight up and down. All right, so it's the best way to, well, maybe not the best, one of the best ways to memorize this thing. We're just gonna say these over and over again. All right, so a function is not differentiable at, and you guys are all gonna shout out, you can unmute your microphones. A function is not differentiable at discontinuities, sharp corners, vertical tangents. Again, come on, you guys have to do it with me. Unmute your microphones, everyone. A function is not differentiable at
Continuities.
Continuities.
Sharp corners, vertical tangents.
Vertical tangents.
again, one more time, come on. A function is not differentiable at
This is
Continuities.
Sharp corners.
Sharp
Sharp
corners.
corners and vertical
Vertical
tangents.
tangents.
There it is, okay. Let me try this one. A function is discontinuous at
holes.
holes.
Gaps.
And gaps. Right back.
Okay, we'll get those better in the future. Let's move down here to example 2. So this is going to take a bit of time for you guys to copy down, but after this example, I have nothing else. It's all blank under here. Okay, so find the x-coordinates where h prime of x is not differentiable, and you have to state why. So I guess all of this should be labeled as h of x, so let's go ahead and do that. This is h of x. All right, so there's a lot of places. Anyone want to find one? What's one of them, one spot that's not differentiable? At x is equal to what? x is equal to, here, I'll start with one of them just so you can see example. X is equal to -5. This right here is an end, which means it's not continuous. And because it's not continuous, it's discontinuous. That means it's also not differentiable. So x equals -5, and I'll say because it's an end. There, done. Okay, another x coordinate. X equals what?
X
1.
Let's do a quiet raise hand so I can call on people.
So
Yeah, Fiona.
X equals 2.
X equals 2 right here. Why is that not differentiable?
Because it's on a vertical tangent.
Vertical tangent, perfect. Vertical, I'm just going to abbreviate tangent. Yeah, Chris, do the next one. You said it earlier, didn't you say 1?
Yeah.
Yeah, 1. So right here. So what is the rationale? What is that?
I don't know.
Okay, well, come back up to your notes. It's one of these 4 things.
Is it a gap?
Is a gap, yep. Because gap. And I should be putting all of these, that these are types of discontinuities. So I'll say discontinuous right there. I'll say discontinuous here. It's one of the 3 reasons, but in that, the first reason, there are 4 subtypes of reasons. So the subtype is end gap. Give me another one, someone. There's at least 3 more. I want to hear from either Teflon or Andrea.
Could it be x equals 8?
X equals 8 right here.
Mm-hmm.
Why?
Vertical asymptote?
Not quite. So the vertical asymptote actually happens only once, and it's right here. It has to be going straight up. So I agree that the slope does get pretty crazy towards 7, but that's not technically a vertical asymptote, or it's not a, wait, did you say vertical asymptote, or did you say vertical tangent?
Asymptote.
Okay, yeah, the asymptote happens at 7. So we can come back here and say at 7. Yeah, so x is equal to 7, and then you said the reasoning already, so I'll write down because vertical asymptote, perfect. And that is a type of discontinuity again. So it's not even continuous, therefore it can't be differentiable. And then Andrea, you do one.
Would it be -4?
-4, right here, yeah, why?
Because it's a sharp corner.
Exactly, we'll say because sharp corner. And actually, sharp corner is the, I mean, it's not super technical, but if you say sharp corner in college, people will know what you're talking about. It isn't one of those things I've made up. And there is one more. What's another one? Anyone? Yeah, Fiona.
5.
5, yeah, why?
Because it's a whole.
It's a whole. Yep. X equals 5 because it's a whole, and that's a subtype of what?
Discontinuity.
Discontinuity, exactly. So I'll just write disc. Perfect. So you found all of the points that it's not differentiable. So graphically, that makes sense. And again, not being differentiable just means that you can't draw that tangent line. It's impossible to draw the tangent line at that point because there isn't even a point. It's impossible to draw the tangent line over here because I don't know, like it's, like I don't even have anything to draw it to. I can't draw a tangent line that goes straight up and down. I can't have a slope that's infinity. I can't draw a tangent line over here. I can't draw because I don't know if the tangent line should look like that or if it should look like that. I don't know what the slope should be. These are all the points that it's impossible to draw that tiny little tangent line. That's what it means to be not differentiable. And now you have the rationale for them too. All right. Are there any questions before we end the notes? All right.